Welcome to part 2 of this tutorial where you get to actually learn about the ellipses. Part 1, I basically broke this into 2 tutorials. Part 1 is a review of perspective, separate from part 2, which is now we get to dive into the actual drawing of cylindrical form. And if you already totally have a good grasp of perspective, then you can just ignore and skip over part 1. An ellipse is like an oval, right? It's the top of, I'm embarrassed to have this giant soda today. I'm not normally a giant soda person, but here we are. So you're looking at this and you can see an oval at the top. It's not a circle, right? It'd be a circle if I aimed it directly flat at you. But if you're looking at it from an angle, it's an oval, but it's a bit squished. It's an ellipse. And depending on where ellipses are in your view, in relation to the horizon and where your eye line is, their perspective changes. And understanding the perspective of ellipses is crucial for being able to draw still lives with ease and even architecture. It just helps to understand what the surface of something looks like as it moves in your view. So as something, I'm looking at a potted plant over here. By learning this, you will be able to way more easily draw your surroundings. I have a stool right in front of me, so furniture and things like that. When I learned it, I was like mind blown. I've noticed not a lot of my students get that part right. My beginner students, they draw things flat because they think, well, this is sitting flat on a table. So they don't realize that they have to curve it, and they don't understand how much to curve the bottom of a cup versus the top of a cup, et cetera, et cetera, et cetera. So I love this lesson. And you probably, if you have this prompt list, you can get one for free on my website, dottington.us. If you have this and you're looking ahead, you're looking at these lessons, some are a lot more technical than others, and they're foundational. Once you learn this, you won't unlearn it, and you'll be able to apply it to all your drawing. And understanding something like perspective just helps you draw better. I hope you'll check out the prompt list, and there's like a little checkbox. You can follow along and track your progress, see where we're headed, and then you can always remember the prompts. Like you could tape this inside your sketchbook and come back to it anytime you need to rejuvenate your art practice. We should dive in and get going on this awesome lesson. So the rule I learned was much later in life was that, here's the horizon, an ellipsis on the horizon. First of all, an ellipsis is an oval, and on the horizon it'll appear to be straight. So you cannot really tell that it is actually in fact round because it's straight. Like hold a roll of tape up to your eyes right now, eye level. You're not going to see the top or the bottom. If you can see the top a little or the bottom, it means that it's not right at your eye level. Remember, the horizon is eye level, and as the ellipse gets farther and farther away from the horizon, whether it's up or down, it's going to get larger. So these are a bit awkward, but I'll make them better as we go. Let's pretend this is actually our roll of tape. So we're going to draw this roll of tape, and from the side, it appears to just be a rectangle. But as it gets higher up, I'm making this curve match this curve. And then this right here is the ellipse, and it is this tall. Now the height of the ellipse will get bigger the farther it is away from the horizon. The height of the ellipse will get bigger the farther it is away from the horizon. So let's continue drawing our tape. And notice that this part, the opening part, it's getting bigger and bigger. This measurement from here to here, from here to here. Those look almost identical, but pretend that this one is a little skinnier, okay? Okay. Yeah, I need to make them even more drastic. So I'm gonna make this one even fatter. Good. And you get where I'm going now, I think. So it will continue, this height of the ellipse will continue to get wider and wider the higher this goes up into the sky until it's literally a circle and you're looking up at it and it's right above you. And it's very circular. So it can keep going, it'll get wider and wider until it's literally a circle. If you want to make this look like a real roll of tape, be my guest, have fun with it. You can shade it and everything. It's not the point of this lesson though, but it's fun. Since this is lower, I'm probably not going to see the top. Like, it's going to be more like that. The same thing will happen as this gets further down. So here's my opening. Farther down it goes. We have to make the ellipse more and more and more circular, right? I made it a bit more exaggerated going down this way to try to make a point. So excuse the awkwardness of the drawing, but I want you to understand the principle above all else, and you can judge away at what the heck is happening with my actual sketching ability right now. We're about to put this into application with an actual still life object. If you're drawing a still life and you've crouched down beside the table so that this is at your eye line, it will appear flat. However, that's not very common. Usually when we're doing a still life, we're looking down at it. So it means that the horizon is way above. The top of my mug, let's say it looks like this. I'm just looking at it at a still life in front of me, and I'm trying to judge this. And I might not get it perfect, and that's fine. But I'm looking at how much of into the mug I can see, and I'm going to estimate that it looks kind of like this. And as I told you before about fudging perspective of boxes by just making things parallel, this is something that you can also do with a cylinder. So as I've done here, I've literally just tried to make this line, this curve, parallel to this one. Because it's close enough to me, that is probably going to work. It is probably going to look realistic enough, okay? You can fudge by making this line, by making the curves parallel, okay? This one, maybe we should, ooh, this one parallel to that one, okay? Yay, you fudged a mug, great. What I see so repeatedly is students will they'll draw the opening of the glass because they know they can see it, or the vase or whatever, and they'll bring down the sides of glass, vase, whatever, bottle, and then they make the bottom flat. Who knows why? Anybody? They make it flat because it's sitting on a table, and they're like, their brains just want to make it flat because it's flat, it's sitting on a table. It doesn't make sense that a curved thing could sit on a table, right? So this is the thing we're going to break you. You're going to break the habit of you doing this. This needs to be curved. You've got a choice. You can fudge it, and you can make it parallel, this curve parallel to this one, and it's going to look pretty realistic. Dun, da, da, da. We have a glass. But if you want to get good at this, there's several things to keep in mind. First of all, you might have noticed I slanted these in because this is closer to us and it's getting farther away here, meaning this is actually smaller than this. That, again, is just me fudging perspective. Didn't even mean to do it. Here I did what's more likely to happen with students, which is just making those parallel as well, and it just kind of makes things more static and less exaggerated. So keep in mind there's a lot going on when you're working on a cylinder. You're actually going to have to make, if it's long enough, you're going to make one side get smaller, whatever's farther away. So if it's on its side and it's heading off into the distance, I'm not making these lines parallel. I'm making them converge at a point on the distance. And this right here, this can be parallel to this, and we've fudged a cylinder on its side. Woo! this opening here is pretty circular because we're kind of in front of it. But if you switch the angle, this circle is going to become more and more of an ellipse, more and more of an oval. So it's narrower because it's not facing us. All the same idea as what I'm trying to teach you here. So you can fudge by making the curves parallel. But what I want you to remember, what I'd love for you to apply is this. The top of the mug or the top of the glass is closer to the horizon here. We'll make it a rocks glass so it just goes straight down. Okay, we'll simplify. But instead of making this parallel to this, let's follow this principle that up here, the opening is this big, but down here, the opening is much larger. So you're going to have to open up the curve. You're going to have to make this measurement bigger. And what will happen is this curve will be curvier. It'll be less slight. So it's slighter up here. See this line right here? See how little it's curved? It's just curved a little tiny bit. But as you get further down here, it's curved a lot more. It's a deeper curve. And so we won't necessarily see the back side of this. Let's say it was not a see-through glass, but the bottom where it touches the table is going to have to be pretty darn curved. So just keep that in mind when you're doing your still lives, that the bottom has to be even more curved than the top for the most part. So I get this all the time. Students are drawing bottles a lot. We just have a lot of them in our still life cupboard. And so here's the top. Comes down. And they'll draw the bottom with like the slightest curve, just a tiny bit of a curve, right? And then this is super open. This should be, because it's closer to the horizon, thinner. This opening, I don't care what size it is. It doesn't matter if it's the bottom of the bottle or it's up here. This measurement from here to here has to be smaller on the top than on the bottom. So they'll do this. Top of mug or glass or cylinder, bottom. See how strange that looks? Do you see how that kind of kills it? This is so narrow. If we continued the circle around, it would be like that. This measurement from here to here, much narrower than the top. It needs to be larger. So the next time you draw a cup, if the top is just this slight angle like this, and the bottom is flat, no, the bottom has to be curvier, rounder than this top. It's hard to explain, but once you start making those slight adjustments, what I would do is just ignore the lesson for a second, just a second. Go and draw a mug, go draw a glass, go draw a bottle on a table, and then go back and analyze how curved the bottom is compared to the top. This shouldn't be the same as this. This, if we're exaggerating perspective, this one will be much rounder than the top. What I love drawing when I'm talking about cylinders is I love drawing a glass of water, because you can show the center of it too. So let's say, okay, right now this looks about to be the same as that. So let's continue it around until we get it to be large enough. This measurement's now from here to here. And the top from here to here, much smaller. Yay, we did something right. Good. But then we also have the surface of the water inside. And if I do this, it's going to look really wrong. Doesn't fit. Because look how small I've made this. This measurement has to be between this one and this one. I'm going to put it over here. So it has to be somewhere between that size and this size. Notice I haven't done any of this with a ruler. I'm just eyeballing it all. But even eyeballing something, if you know the concept, you'll do better. So my goal is to make this measurement bigger than this one. Looks kind of the same right now, doesn't it? We've got options. We can make it larger, or we can make this even smaller to exaggerate. Okay, from here to here. I think that's bigger. I need a ruler. 1 centimeter. Ooh, 1 and a bit. Let's make it 1 and a bit more. And then this one's going to be 2. Okay. So we're going to make this one a little larger than I had it, a little more exaggerated. And then this one's much taller than this one. So we did good. Now, whoops. It does not matter this way. It does not matter how wide they are. That's not really what we're talking about today. Because we are dealing with perspective, it's great to note that things will recede as they get farther away from you, but that's not why I put these angles on. I put these angles on because like a pint glass or a water glass is often slanted this way. Now, with any subject matter, the ellipses matter. So this is a saucer, and if it's at the same level as the bottom, then those ellipses will be the same height. But they'll be different from what's on top. So I'm looking at the cup. I am not looking down at it. I've crouched myself down, so I'm looking at the top of the cup. This measurement is not the same as this one. This one is rounder. But the saucer is going to be pretty similar to this bottom one because it's at the same level. So it's a different size because it's a saucer. It's way larger. Let's say we were looking at the cup and saucer from a lower angle. So I'm kind of like looking at it from the side, and this ellipsis is tiny. This ellipse is tiny. And then the bottom is slightly more curved than that, and so it works. This is correct in itself. But if I add the saucer, which is at the same like height as this, and I make it super round, it doesn't fit. It looks wrong. This looks flat on it. It's very bizarre. This has to be the same proportion as the bottom of this. So it works over here. The center of this saucer is where the glass or mug is sitting. And this ellipse right here is just blown up, same dimensions as the saucer. Make sense? And so they match. They look like they're on the same level. Whereas if we're looking down at the saucer and cup, so far down that the top looks like this. I'm going to move the cup over so I can actually look down on it. So let's say we're looking down at it. In fact, we're looking so far down at it, we can see the inside of the cup a little bit. we can't then make the saucer like narrow, like this, like when we were looking at it from the side. The saucer has to be the same dimensions as what it's basically touching. It's basically touching the bottom of this. So if we just make that circle, or ellipse rather, if we just make that again bigger, try to keep it like, keep the dimensions pretty much identical, just make it larger. I know I'm making like a million circles here. Oh my goodness. It's just because sometimes like much easier to draw something circular when you put your whole arm into it. So I've tried to make the saucer the exact same shape as the bottom of this cup. Therefore, they will match. They will look like they're supposed to be together. They're sitting on the same plane. This matches this matches this, right? These are more open. And it, whoa. This one doesn't match. This is too narrow and this is too open. If you're looking at a cylinder, like a paper towel roll, and it is right on the horizon, meaning you've crouched down and the top of the paper towel roll is above your eye line. It's above where you're crouched. You're going to see it curving this way. And then if this part is below your eye line, you will see it curving this way. Okay. Now, if you cut it in the middle, what curve would you have? If you cut it right where your eyes are, it would look absolutely straight. If you cut it a little bit below, you're going to have a curve. It might not be a big one, not as big as this, but you're going to see the top. You won't see, let's say it's not see-through, we won't really see this back part. And if we cut it here, we will see the bottom of it. So things above you, you see the bottom of. Things below you, you see the top of. When my students are trying to draw chairs in our room, they're trying to draw furniture and they're trying to draw it in perspective and they don't know where the horizon is. This is very common. If you don't know where the horizon is, don't feel weird. You have to have someone tell you to do this in order to ever understand. If you don't know where the horizon is, ask yourself, can I see the top of this item or can I see the bottom of this item? So if it's a chair, I know we're getting really into the perspective now, but this matters for the ellipses as well. So if it's a chair, let's say this is a dining room chair, and you're like, where's the horizon? I don't know. And here's my chair. Lovely chair. And I have students say, I don't know where the horizon is. What do I do? Where do these lines recede to? If you can see the top of the chair, which we totally can, right? And you can see, you're gonna have to look for all the tiny details. You'll be able to see the top of each of these rungs, the top of each of these pieces. If you can't see the top here, then that means it's at your eye level. If this is the chair you're looking at, and you cannot see the top of the chair and you cannot see the bottom of the chair, then that is your horizon. Makes sense? But I hope that just by watching this and thinking about it, you become a better drawer. I imagine that if you're anything like me, when you learned this, you were excited, sometimes a bit baffled, but you never really thought about how perspective is applied to ellipses and circles in general and how those end up in perspective. And that just by watching this and thinking about it, you get a better understanding of what you're supposed to be looking for. It doesn't mean you're going to watch this tutorial and suddenly you'll be able to draw everything with perfect perspective. Even I have to kind of like puzzle through things before I figure them out. But this should give you a basis from which that you can observe better. My goal here is to help you observe your world better so that you can translate it into drawing. And maybe you followed along and you did all these sketches with me, and now you have a sketchbook with all these little fidgety drawings in them. I love pages like this. I love looking back at them. I don't know why. I guess because a sketchbook is this magical internal workings of your brain. It's showing how you're figuring things out. But I'm rambling. I just want to say thank you for joining me on this maybe strange tutorial today. And I will see you again soon for another one. Bye.